Welcome to my kitchen. So Jason sent me an email asking about a couple of these. So I'm gonna do 5 from the practice problems and then 7 and 8 from the unit 1 review, multiple choice, I'm assuming. So first one is about a paramecium here. 100 micrometers long, models as a sphere. How much propulsion forces it need to exert to swim at 0.99 or 0.90 millimeters per second. So basically what we got to do is, because it's moving at constant speed, we got to figure out what the drag force is, because if we can figure out the drag force, then we can figure out what the propulsion force has to be in order to make it move at constant speed. So over on the left side here, it gives us the equation for a small object moving in a liquid. Drag force is equal to B times V, where B is this constant 6 pi eta times R. So I'm actually going to write that down real quick. Mastering problem number 5. Drag force is equal to B times V, where B is equal to 6 pi eta times R. All right, so if we can figure out that, all we have to do is multiply that by the velocity that we're going, and we can figure out our problem. So 6 pi R, it gives us the viscosity of water, right? 20 degrees Celsius. Viscosity is 1.0 times 10 to the negative third. So that's our eta value. So 6 pi times that. And then our R value gives us the whole length. So I think we're going to have to cut that in half and make that 50 micrometers. So that'll give us that there. So we'll come back here. We've got B is going to be equal to 6 times pi times 1 times 10 to the negative third, I think, times 50 times 10 to the negative sixth. Because it's micrometers, we need to make that to the negative sixth. Did I get that right? 1 times 10 to the negative third. Yeah, times 10 to the negative sixth. All right, so there's that. We multiply that out. I can do it real quick. Hold on. 6 pi 1 times 10 to the negative third, 50 times 10 to the negative sixth. And we get, this calculator's so old, 9.42 times 10 to the negative seventh. For B. And then we just have to multiply that by velocity. So D is equal to 9.42 times 10 to the negative seventh times 0.9 times 10 to the negative third meters per second, right? It was in millimeters. 0.9 millimeters per second. So yeah, times 10 to the negative third. There's our velocity. We multiply those two and we get our answer. So times by 0.9 times 10 to the negative third, 8.48 times 10 to the negative 10th. Let's see, that's 2 sig fig, so 8.5. Let's check it. 8.5 times 10 to the negative 10th. Unit would be newtons. Cool. So there we go. How about a propulsion force of a 2.0 micrometer? E. coli bacterium swimming at 4 micrometers per second. So we do the same thing here, right? I could probably just do it in my calculator right here. 6 times pi times eta, which is 1 times 10 to the negative third, times diameter, which, or not diameter, radius, so 1.0 times 10 to the negative sixth, because that's half the diameter. So that gives us our B value, and then times velocity, so times 40 times 10 to the negative sixth gives us 7.5 times 10 to the negative 13th. And it's a force, so newtons. There we go. Proportion very small, so the order is judged by the proportion large or small relative to the order. Compute the acceleration that the approaching force could give each organism if there were no drag. The density of both organisms is the same as that of water. Compute the acceleration that the propulsion force could give the paramecium if there were no drag. So we need the mass of a paramecium. Did it give us the mass? It gives us the density. So if we're assuming that they are spherical and we get a density, we just have to multiply by their volume to get a mass. So volume of a sphere is 4/3 pi r cubed. 4/3 pi r cubed. I think that's the volume of a sphere. 4/3 pi. For the paramecium, the radius was 50 times 10 to the negative sixth. I guess I should show you guys what I'm doing and not just do it in my head right here. So we're calculating the acceleration of the paramecium. So in order to find acceleration, right, we need force and we need mass. We figured out the force already, right? That's what we got for part A. We need the mass, but they don't give us a mass. What they give us is a density. So mass is density times volume. So I'm looking for the volume of the paramecium because it says they both have a density of about 1,000, or did it just say the paramecium? Both organisms is about 1,000 kilograms per meter cubed. So we have the density. All we have to do is multiply the density by the volume. So I'm trying to find the volume, which I believe is 4/3 pi r cubed. So if I can find the volume of the paramecium, which I'm doing right now, 4/3 pi r cubed, 5.23 times 10 to the negative 13th. So I got a volume of 5.23 times 10 to the negative 13th for the paramecium. So we can just multiply that by the density, which is 1,000. So 1,000 times this number will give us the mass. So we multiply that by 1,000 and we get obviously 5.2 times 10 to the negative 10th. Kilograms. So there's our mass, and then we just have to use the force from the first part. So the acceleration is going to be whatever our force was. I'll have to go back and look, divided by 5.23 times 10 to the negative 10th. So our force was, for the paramecium, 8.5 times 10 to the negative 10th. So 8.5 times 10 to the negative 10th divided by our mass. Oops. Gives me 1.62 as the acceleration. 2 sig fig, so 1.6 meters per second per second. Incorrect. It doesn't like my units. I guess it didn't like how I put units per second per second. That was messed up. Meters per second is meters per second squared, whatever. So same thing with the paramecium, or sorry, with the E. coli, right? 4/3 pi r cubed. There's the diameter right there. So 4/3 pi, radius is 1 micrometer. 1.0 times 10 to the negative sixth cubed. 4/3 pi r cubed. That gives me the volume. Then I'm going to multiply that by 1,000 to give me the density. So that's 4.2-ish times 10 to the negative 15th. And then I want to take the force that I solved for, so the 7.5 times 10 to the negative 13th, and divide that. So 7.5 times 10 to the negative 13th divided by what we got there. And we get 179, which is super fast. 2 sig figs, so 180 meters per second, and I'll do squared this time. There we go. All right, so there is number 6. I'll get back to you in a second with 7 and 8 from the College Board.